All right, here we go. On the fourth and final page, this whole page was worth bonus, and I only graded one of them. So if you circled question number one, I would grade number one, or if you circled number two, I would grade number two, or circle number three. But if you got your bonus question right, I gave you an extra 3 points, which was 10%, which was a very healthy bump here, because I think these are all pretty challenging questions. So let me go through these three. Let's take a look at number one first. It says the figure shows triangle ABC is inscribed in circle D. It says that the measure of CBD is 44 degrees. And I need to find the measure of angle BAC. So I need to find this angle down here. So a whole lot of stuff going on here. The first thing you need to know is as I look at triangle BDC, BD is the same as DC because they're both radii. So that makes this triangle an isosceles triangle. So base angles have to be congruent. So over here, angle BCD is also 44 degrees. So now my triangle BCD has to add to 180. So 180 minus 44 minus the other 44 leaves me with 92 degrees. So this angle on the inside is 92 degrees. Well, if that angle is 92 degrees, then arc BC is 92 degrees, because a central angle is equal to its intercepted arc. And now finally, to get to the answer, the measure of angle BAC, that is an inscribed angle, and it is equal to half of the intercepted arc. So I have to do half of 92, which is 46 degrees. So bonus number one, 46 degrees. All right, let's jump down here to question number two. The figure shows a circle with center P and an inscribed isosceles triangle ABC. So it's isosceles. These two are the same. It says if AC, segment AC, has the same length as the radius. So if this is a radius, what is the measure of angle ABC? So what is this measure up here? All right. So this one was a little tricky because the first thing I want to do is I want to put in two radii. And I'm going to connect P to A with a radius. And I'm going to connect P to C with a radius. So they're all radius, radius, radius. That makes this triangle, by definition, an isosceles or a equilateral triangle. All the sides are the same, which means all of its angles are 60. So 60, 60, and 60. So now my central angle, APC, is 60 degrees, which makes arc AC also 60 degrees. That is also 60 degrees. So now let me get rid of some of this stuff in the middle. Because now as I look at this, now it's pretty easy to find angle ABC that is an inscribed angle. So an inscribed angle is equal to 1/2 of the arc, and half of 60 is 30 degrees. It's 30 degrees. And finally, the last. Question number 3. It says for circle K, find the radius R. Okay, so now I have to make a little admission here. There are two ways to go about this, and one way is wrong. All right, so I'm going to show you the right way first. All right, now the right way is I want to think about this because this is tangent. I know that I have a 90-degree angle here, and I can use Pythagorean theorem. So a squared plus b squared equals c squared. So the legs are r, so r squared. The other leg is 12. So r squared plus 12 squared has to equal the diameter. I'm sorry, the hypotenuse. This is the hypotenuse from K to G, and that is 2 segments. That is a segment that's 9 and a segment that's R, so 9 plus R squared. All right, so that's R squared plus 144 equals, and now I have 9 plus R quantity squared, which means I have to do 9 plus R times 9 plus R, and I need to FOIL this thing, if you remember FOIL. So 9 times 9 is 81. 9 times R and R times 9 are both 9R, so that gives me 18R, and then R times R is R squared. And when I want to, now I'll subtract R squared on both sides. That's very nice, because it gets rid of all of my R squareds. So 144 equals 81 plus 18R. Subtract 81, that is 63 is equal to 18R. Divide by 18, and R is 63 divided by 18 is roughly 3.5. Maybe it's exactly 3.5. All right. That is the right answer. Right? That's the right way to do it. The other way that I saw some people do it, and mathematically it's not wrong, however, the problem with this is not that I have a question wrong, it's just a matter of there's a part of this that says 68 degrees here, and that can't be right. All right? So if I try to use trig here, if I try to use SOHCAHTOA, and I want to find R, so if I'm looking over here at R, I have the adjacent, let me take a look at my angle here. I have my opposite side and my adjacent side. So that would tell me that I'm going to use tangent. So I would try the tangent of 68 degrees. And the tangent of 68 is equal to the opposite 12 over the adjacent, which is R. Multiply both sides by R. And then divide by tangent of 68, so R equals 12 over the tan of 68. And if I do 12 divided by the tangent of 68, I find a radius of something real close to like 4.8. And we know it can't be 4.8 because if I were to plug that back in, then Pythagorean theorem would not work. So this, I did give credit for in green, but this answer is actually a wrong answer. All right? It is not going to work, not because you did the math wrong, because the problem itself is wrong. That 68 just should not have been in there. We should not have put that in there at all. So hope this helps. If you have any questions or if you want to schedule time to retake this, just let me know. All right, guys, have a great weekend.